This is your tutorial on adding and subtracting rational numbers. If you take a look here, rational numbers are just numbers that are ratios. See the word ratio here? And one way you can express a ratio is a fraction. So rational numbers are numbers that are fractions, and we're going to be adding and subtracting both positive and negative fractions today. Before you do that, it's really important that you understand why we go through the processes that we do. It's not enough to know what to do, you need to know why you're doing it. So we're going to try to show you that in a visual way today. Taking a look at a very basic problem right here, 1/4 plus 1/4. You can imagine a situation like this in your head. Like, for example, if I eat 1/4 of a cookie during lunch, and then I eat another fourth of the cookie after school, how much of the cookie have I eaten? And it's pretty obvious there that it's going to be 1/2. But I'm going to show you how you could find that using what are called fraction tiles. So this right here represents 1 unit. And I want 1 unit split into fourths. So I'm going to add some more parts until I have 4 parts. And the numerator, 1, tells me how much of that fourth I have. So I have 1/4. If I had 2/4, I would fill this one in, 3/4, and then of course the whole fraction tile would be 4/4, which is 1. So for the bottom fraction, I'm going to do the same, break it into fourths, and fill in one of those fourths. When you're adding fractions, your goal is to get them together. So I have a fourth here that I can actually put up here with this fourth. And now I can see that I have 1/4 plus another fourth, which is 2/4. But I can also see that if I break it down into just 2 parts, it's just half of the total. So a fourth plus a fourth is a half. We're going to use those ideas to address more difficult problems, starting with one where you do not have a common denominator. Denominators are the bottom numbers, so this just means 8 and 4. They're not the same. But let's take a look at what that does in the problem. I'm going to split the top fraction tile into eighths, or 8 parts. I'm going to split the bottom one into fourths by making 4 parts. And for this one, it is 3/8, so I'm going to have 3 of those parts filled in. And this one is fourths. So I have 1 of the 4 parts filled in. If you notice, the eighths and the fourths, they're not the same size. So I can't put that down here. You see how it didn't let me put it down here? Which means I need to find a way to make these the same size. Now I can try to make the eighths bigger pieces, but that's a pretty hard process to do. So what we're going to do is take this piece and split it into smaller ones. It's kind of like we did with the Cuisinart rods. If you remember, sometimes we had a red and we couldn't combine it with something else, so we had to turn it into 2 whites instead of 1 red. Those were equivalent fractions, and we're going to do the same thing here. So I'm going to change this to fifths, and you notice here it puts it in red, and here are my fourths. They're the dashed lines, and the solid lines are now fifths. And we only can combine it with these when they're the same size of pieces and when the 2 parts that we have it divided into are matched up, and it's not, and this is red, so we know that's not going to work. So here I have it in sixths, and you know, that kind of looks close, but no, not quite. So we're going to keep going, and that's not it either. You can see the dashed and the solid are not lined up. But when we get to eighths, you'll notice that the dashed and the solid are at the same place. And that's because 1/4 is the same as 2/8. So I can take these 2/8, and to it I can put, I can take these 2/8, maybe I can't take them. I can take these 2/8 and mentally move them up here with these. So if I have 2/8 down here, I'll just fill in 2 more up here. Okay, so now do you see that all of the eighths are together and we have 5/8 filled in? 5/8 of the total. If you have negative numbers, It's not all that different. We're just going to use colors to represent negative. So I'm still going to have 1/3. So I divide it into 3 parts. But to show that it's a negative 1/3, I'm going to use a red, kind of like with red tiles when we did adding and subtracting integers. And then for this, I'm going to split it into fourths. And 3 of those should be filled in, and it's positive. So I have positive 3/4, and I am adding a negative 1/3 with that. So if you notice here, our pieces are not the same size. So I like to start with the one that's broken into fewer pieces, and, and that means its parts are bigger, so I can cut it down more. So if I break it into fourths, which is what I needed fourths, you notice these fourths match up. That's the same size, but the red is not landing on any of those fourths. So that means I have to keep going. So I'm just going to go up till the next part amount matches up with my fractional amount here. So fifths doesn't work. Now you'll notice sixths here. The 1/3 line and this 2/6 line matches up. So I'm going to increase this to sixths, and yeah, that's not going to work. So I'm going to keep going. I'll try ninths, and oh, that's close, but not quite. You can see it's still in red. So I'm going to try the next thing, whatever it is. Tenths does not match up. 11ths, nope. But I can express negative 1/3 in twelfths, because negative 1/3 is the same as negative 4/12. So I'll try to express this in twelfths. Okay, so 3/4 can be expressed in twelfths. You'll notice here we have 3, 6, 9 pieces filled in. So 9/12 is the same as 3/4. But what you should notice here is that we have 2 different colors. And when you have the red and the yellow, that represents a positive and a negative. And if you have a positive and a negative, which are opposites, they're going to cancel each other out. Like a positive 1 and a negative 1 together bring you back to 0. So all of these right here are 0 pairs. See them stacked up? So the only things we have left are these pieces right here. So if we cancel out our 0 pairs and count how many pieces we have left, we have 1, 2, 3, 4, 5 twelfths that are left. So what did we do mathematically here with negative 1/3 plus 3/4? Let's take a look. If I have negative 1/3 plus 3/4, I split those fraction tiles into pieces that could be the same for both. So it was all based on how many parts it was broken into. And if you look here, we have thirds and we have fourths. So if we have thirds and fourths and we're trying to get them into the same size of pieces, what we're going to do is look for a multiple of 3 and 4, because every multiple is going to allow us to cut it into that number of pieces. So for example, with the thirds, we could break it into sixths, we could break it into ninths, we could break it into twelfths, we could break it into 15ths, and so on and so forth. With the fourths, well, after fourths, we could break it into eighths, and then we could break it into twelfths, and then we could break it into 16ths, and so on and so forth. We don't have to keep going, because if you notice right here, we have twelfths and twelfths, and that's our smallest common denominator. So when we're adding and subtracting fractions to find a common denominator, that's what you're going to do. You're going to look at your denominator and figure out what the common multiple is for those denominators. So now that we've done that, we're going to need to express each fraction in terms of that denominator. So if you look back here, when we broke negative 1/3 into little 12th size pieces, we cut every third up 4 more times. So we have 4 times as many little pieces as we did the big ones. So what we're going to do is represent that mathematically. We're going to times it by 4. Notice that makes 12. Okay. But I'm also going to do that to the top, because every piece was cut into four smaller little pieces. So now I have 4 times negative 1, which is going to be negative 4. And I have 4 times 3, which is 12. And you'll notice that negative 4/12, if you reduced it, would be negative 1/3. But you don't want to reduce it here. I hope you know why. So over here now we have fourths, and we need it to be twelfths. So that means we're going to need 3 times as many little pieces. So 3 times as many little numerators and denominators. And you'll notice that that would mean we'd have 9/12. And if you go back to our diagram here, um, we see that we had 3/12, 6/12, 9/12. So that indeed matches. And now that you have your problem into common denominators, all you have to do is look at the tops, the numerators. Okay? Once you solve this part, that tells you how many little pieces filled in you have left. That tells you your numerator. So we have negative 4 plus 9, and with our work with integers, we know that that's going to be positive because this would be 4 red tiles, 9 yellow tiles, or you could say this is 4 stinks, this is 9 smell goods, so we smell good, or we have yellow tiles, and in fact we have 5 of them. But they're all tiles that are still broken into twelfths. So we have 5/12 of a whole. And that is how you add and subtract rational numbers. So I want you to try one more for me. Let's say you have negative 2/5, and to that you're going to add negative 3/7. I want you to think about what kind of denominator you're going to need, how many little tiny pieces you need it cut up into, then figure out what you're going to have to multiply each fraction by to make it, and then do your math from there. So I'm going to give you a second to try to figure out what your common denominator should be. Now, if you are not sure and you're ready to see what it should be, I'm going to write it here. Don't worry, it's disappearing ink, so it will disappear shortly. If we're going to break it into 35ths, we need to take each piece and multiply it by something, so we have that many more little pieces in it. So if we have negative 2/5, we'd need 7 times as many little pieces as we had the big chunks. And over here, if it's broken into sevenths, to get it into 35ths, we'd need 5 times that amount. Okay, so this is still disappearing, so if you're not following along, you're going to be in a little bit of trouble. So if we multiplied this fraction by 7, we'd have negative 14/35 plus negative, this one got multiplied by 5, so we'd have negative 15/35. So we had negative 14/35 and negative 15/35. Putting it together, we have negative 29/35, which if you think about it on a number line, we're going to pretend that's straight. Here's 0, here's 1, here's negative 1. Negative 29/35 is going to be close to negative 1. Okay? And if you imagine what we had here, negative 2/5, well, negative 2/5 is pretty close to negative 1/2. And negative 3/7 isn't quite negative 1/2. So if we have negative 1/2 and another negative 1/2, it's going to get us pretty close to negative 1. So you can judge how reasonable your answer is based on the original problem and a little bit of estimation. So that's adding and subtracting rational numbers. Hopefully this helped you a little bit. If you still have questions, you know what you can do. Otherwise, try some problems on your own.